Jai Janendra, Namaste and welcome to my channel. Today we are going to solve the 100th question of the problem solving series and the 10th question of the topic trees. The difficulty level for this question is medium and this question has been asked in Amazon, Microsoft, Paytm and many other companies. So root to leaf paths. So we are given a tree, its root, and we need to find all the possible paths from root to its leaf node. Okay, so here in this case, you can see there are two leaf nodes, 2 and 3. So from root to reach to the leaf, whatever is the path, we need to return it. So there will be multiple path. Since there will be multiple leaf nodes, so we will return a 2D vector that comprises of all the paths. Okay, so you can see this that we have 1, 2 as a path to reach 2. There is no other path for reaching 2. Obviously, there will be one path only to reach the leaf node. So 1, 2 is the path and there is another leaf node 3. So for 3, 1, 3 is the path. So this would be our answer. Here in this case, we have 3 leaf nodes 40, 60 and 30. So to reach 40, we have to traverse like this from 10, 20, 40. Then 10, 20, 60, we reach the leaf node. And then to reach 30, we'll have 10, 30. Okay, so this would be our answer, root to leaf path. Now how do we solve this? First, tree is a hierarchical data structure. So most of the problems till now we have used recursion in trees, right? So we have already studied recursion, we have solved questions on recursions and backtracking. So we have to find the base case, we have to find the relation between the problem and divide it into sub problem, find the relation and then generalize it, right? So since it's a hierarchical data structure, so whatever happens for the root, same thing we do for the its subtree, either it's left or right. So we have two subtrees, right? Now to find the root to leaf path, we need to go to the leaf, right? Now how do we know a node is a leaf node or not? A node is a leaf node when it doesn't have any left child or right child. Okay, there is no left child and right child of the node, then it is a leaf node. So if we entered the leaf node, we'll know when it doesn't have a left and the right child, we'll know it is a leaf node. So once we have reached the leaf node, whatever the path we have traveled, if we store it in a vector, then that path we can add to the 2D vector that we need to return. Okay, so the generalized condition would be if the root doesn't have the leaf node, left subtree and the right subtree both are null, then we have reached the leaf node. Okay, now what would be the base case? That if root is null, then we return, right? If the root is null, then we won't be going anywhere, right? So if it is null here, the left is null, so we are not visiting it. And the third thing is we need to go to the left also and go to the right also. Okay, so these are the cases and we have to return 2D vector, so we have to store the path every time. So once we store a path, like from here, when we go to the left, again if we go to the left, we have stored this path, we need to store this path 10, 20, 40. So when we go here, we see okay, it doesn't have a left, it doesn't have a right. We store this path, so this 10, 20, 40 has to be stored in a vector, and since it is a leaf node, we will add this vector to a 2D vector. Now once we are done here, and when this should be done, and when we go back here, since we have inserted that 40 to the vector, we have to pop it back again, right, every time. So that backtracking we have to do because we are entering the whole vector to a 2D vector. Let's code it, you will understand what I want me to say. Okay, so first let's take the vector of vector int result. Okay, then let's take a temporary vector int temp. Okay, and then let's call the recursive function find paths, where we pass root, we pass temp, and we pass the result vector. Now here we will use recursion. This would be and at the end we would return result. This would compute result vector and we'll return this. Now here void find paths, it would be a void data type. Since we will be doing recursion, we don't want anything to be returned as a vector. We will pass this as a pass by reference. So tree node strict root vector int ampersand temp, okay, comma vector int ampersand result. Okay, now okay, we are here. Okay, so here one thing we can do here, if root is equal to null, we can return result. Okay, no need to compute anything, it would be an empty 2D vector. Now here, if root equal to null, return. Okay, now if it is not null, then what do? We will add this temp dot pushback, whatever the value is there, right? Root value, we will add it to temporary vector. Okay, now if we see, if root left equal to null and root right equal to null, that means if it is a leaf node, then what we do? We will add result dot pushback temp. Okay, we will return result dot pushback temporary vector, whatever it will be there, we will store this, okay, into the result. Else, if it is not a leaf node, then we have to go to the left part and the right part. Okay, so else what we will do? We will call find paths. We'll call the root left. It's a subtree. Same thing we have to do for the left subtree. Root left temp res, and find paths. Same thing we will do for the right subtree. Root right temp res. Once we have done this, okay, so at the end we need to pop out the element. So recursively when we will solve this and like this, so the root left, again root left. Once we have done reach this part, this is the leaf node, and we have got this 10, 20, 40, and once this operation is done for this, its left leg doesn't exist. Okay, so then we will pop out this element. Okay, we don't need this 40, so that when we go back here, we don't have 40 inside our temporary vector. It can go to the next part. Okay, so we will temp dot pop back, we have to do this backtracking. Okay, yeah, so yeah, this is the way we'll get our answer for this. Let's dry run it for this example. Okay, this is the tree we have got, whose root is at 10. Okay, so it's not null, so we will push the temporary vector with 10. Temp will be 10 now, right? Then we see, okay, is it a leaf node? It is not a leaf node, it has left and right child. So we'll not go here and we'll go here. So we'll call find paths root left. So again we call this left 20. For 20 this find paths would be called. And now 20 is not null, and we'll push this temporary vector 20 into the temporary vector. Okay, and okay, we'll not go to this condition. Again we'll go to this condition. So 40 here it will come. 40 also we will insert. Okay, and now when we reach 40, we'll see, okay, for 40 the left is null, right is null. So we'll enter this result dot pushback to the temporary vector. Okay, and we can actually return here, so that we don't need to travel again. Okay, so this 40 would be inserted, so this result, inside the result 10, 20, 40 would come. Okay, and now since we have returned, so for 40 it is done. So this 40 done. So again this part is done. This part would be called. Left part is done. It has returned. Now right part would be called, and for this 60 same thing would be done. Okay. So when that point of time when it was called here, temporary was having in the temporary vector was different, but when it comes over here, right, that point of time temp will not have this temp, whatever this temp is there, this temp will not have 40 stored. Okay, so it will have 60. So this 40 is done actually, because this temp is different temp, but we are passing by reference. So what we have to do here, this should get this 60 here. So once we are calling this result.pushback temp 40, okay, then we will not return. Okay, so once this is done here, 40 is done, this root left 40 left would be called, this would give us null, right would be called for 40, this would also give us null, and then we'll pop back 40 here. So return is not required. Pop back 40, now 20 is done. So this functionality is done. Then that's why dry run is very important. Now this root right would call. So this 60 would be called, then 60 we will add, and then we will check, okay, if it is a leaf node, and then we will add this 10, 20, 60 into a resultant vector. And then for this 60, once we have added, we will go to the root left is null, we will return, root right is null, we will return for 60, and then we will pop out this 60 as well. So now we are at 10, 20. Okay, so for 10, 20 we have done. So for 20 we have got to the left, got to the right. Now we will pop back the element 20. So 20 would be popped out. So now for left we have done. Now we will go to the right. Okay, so temp right root 30. This 30 is called. Now for 30, when for this 30 it is called this find paths, we see it is not null, and then we'll insert this 30 here, 10, 30, and now we check, okay, is it a leaf node? Yes, it is a leaf node because it doesn't have the left and the right children. So we'll insert 10, 30 inside the resultant vector. Now we'll call this for 30, root left, it is null, it would return 30, it would return, and then 10 will pop back this, and anyways we have traversed all the things. So for 10 we have, for this 10 we have traversed this whole code, all the things have given the result. So this function will be done and the result will have this answer. Okay, I hope the dry run is clear, the code is clear, the link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 100th question of the problem solving series in the Geeks for Geeks platform. Route to leaf paths. The difficulty level is medium, and you can see these companies Paytm, Amazon, and also Microsoft has this question. I've seen it before in the Microsoft interview questions. So here we have discussed both the examples, and let's look at the code. The code is the same that we discussed. Okay, you can see we are pushing the elements and then we are backtracking. We have added this condition, and this is the basis, this is the termination condition to check, okay, that it is a leaf node, not root left. That means root left is equal to null. Okay, so let's submit this. As you can see, the code has been accepted. The code is right. Okay, I hope you have understood this question. You have understood recursion used here, backtracking used here, and the logic that we have used to solve this route to leave all possible paths. So see you all soon in the next video, where I'll be explaining the 101 question of the problem solving series and the 11th question of the topic tree. Jai Jinendra.